Okay, so today we're gonna be working on an iPad Pro 10.5 inch that was mailed to us for no power. The tablet was working. Customer changed the display on this tablet and afterwards the screen went black. Nothing comes on. Now I did notice when I plugged the charging port in, I do hear a ding sound. So that means the tablet is powering on, but there's no display on the screen. We do not see any dim image, we do not see nothing, so no backlight and no image. What I want to do is look at the circuit inside to see if we see anything obvious. Remember, there's no circuit diagrams available for this tablet and there's no board diagrams available for this tablet. We're going to do a physical inspection on the board to see if we see anything obvious. Any work that's going to be done on this is going to be based on my experience and my personal input, trying to figure out how the circuit works and why there's no display or backlight on this tablet. So the first thing I want to do is a physical inspection on the board to see if there's anything obvious. We may be able to tell if there's a blown component or a missing component. That's step number one. What I want to do is look at the FEC connectors here where the screen connects. I want to see if there's any damage onto the FEC connector. I want to see if there's any damage to the components that's above or under the FEC connector. And right off the bat I see a missing component right here. What is this missing component? I do not know, but we're gonna try to figure out what that component is. Let me continue the inspection. This component here could be a backlight filter. We do not know, it doesn't look too good. So everything looks good here. I do not see anything obvious. And this one, I don't think this is anything here. We always have to be aware of what's going on. Now, what is this component? Is it a filter? Is it a capacitor? Is it an inductor? We do not know. And what I'm going to do is put the meter in diode mode and we're going to test both ends of the missing component. If we see that one end connects to ground and the other end does not, it could mean that this is a bypass capacitor. Bypass capacitors has one end that connects to ground and the other end connects to somewhere else on the circuit or to the FEC connector. A resistor will not connect to ground. An inductor will not connect to ground. So it's only a bypass capacitor that will connect to ground. Just a moment. Hello, how are you?
What you charge to replace screen?
Which one is this? So we have the meter in diode mode and let's go ahead and test right over here. Red probe on ground and black probe here. And there's a beep, which means that this pad is connecting to ground. What about the other one? The other one is not connecting to ground. So one end is connecting to ground and the other end is not. That tells us that this is a bypass capacitor. A bypass capacitor is not going to prevent the display from coming on and it's not going to prevent the backlight from coming on. It's just there to filter high frequencies. It's not a big deal if it's not present and it's not going to stop the circuit from working. Out of curiosity, let me just test the components next to it. One end is good and the other end is ground. So this is a bypass capacitor as well. That's a bypass capacitor as well because one end of the component is connecting to ground and the other end connecting to ground. So all those are bypass capacitors. What about these here? Same thing. So everything is ground from this side. And none of the pads on top are ground. That tells me that all those components are bypass capacitors. Okay, so all these are capacitors and all these are capacitors. The one that I think is a filter that doesn't look good, let's go ahead and test it. So is this one continuous from here to here? And yes. Where does this filter connect to? We do not know. right here. It connects here. Okay. We do not have to replace this component because it's a bypass capacitor, but let's say this component was a filter, then I would take it off an iPad Air and put it here. But for now, this component is not going to cause display and backlight not to come on. The filter is good. Most of the components here are bypass capacitors. That's a filter. It's good. It's continuous. So all these components are good. I mean, we have to use our experience working on older iPads. iPad Air 2, iPad Air, iPad minis. And we have to use common sense. And we have to do a physical inspection. We combine all those three together to try to figure out the problem. Now I'm gonna rule anything on this side of the board as being bad because everything looks good here except for the missing component and the other one that we thought may be bad, but it turned out to be good, the filter. Let's check the other part of the circuit, but just give me a moment. Okay, so all the customers came in at the same time. Let's get back to this. I forgot where I left off. So we did notice this cracked diode here. This diode is most likely part of the backlight circuit, but right now we do not see an image or a backlight on the screen. But my experience with the iPad Pros is if there's anything wrong with the backlight, we do not see an image on the screen. Right now we do not have an image on the screen, and this diode, I'm almost positive that this belongs to the backlight circuit, and obviously it's cracked. Now there should be another one for the backlight. Unless there's only one on the circuit. Or it could be somewhere over here. So we have to cut this piece off. I do not want to damage any components under the shield, so we have to be careful. Yeah, right there, this is the diode also. So the second diode is right over here. And we do not know if that diode is good or not good. Is it cracked? Yes, I think so. Alright, another customer, just a minute. Hi, how are you?
I need a battery for this phone. This is Samsung.
Usually when one diode blows out, it causes the other one to go bad. Let me do a quick measurement using the diode mode to see if there's anything obvious. One 1.3 is not good. 1.9, 2.1. This diode is bad. This diode is not good. Let me measure a well-known good diode so I can show you what I mean. Any more diodes here on the board? Here. Let's, for example, test this one here. And on this one we get 0.1, 0.14. That's a good diode. And on this one we get 0.14. That's good. Values for good diodes should be somewhere in that range. 0.14. The other one, the two diodes that I suspect are bad, one of them is cracked. Let me show you how much it's measuring. So that's one of them right here. You see 1.6, 1.7, 2.1, 2.3, 2.4. That's bad. And the other one where we had to peel off that metal thing from on top of the component is measuring 2.7, 2.9. So these diodes have to be changed, and hopefully by changing both of them, this tablet will work again. So let's start by doing this one. We should have these diodes in stock, or we can just pull the diodes off another iPad, like an iPad Air or earlier versions of the iPad. So let's remove this diode. We're gonna use hot tweezers to remove this diode here and the other one. Okay, so I'm using a little bit of hot air because the hot tweezers, I have the small tip here, the big tip fell on the floor and it got damaged. The small hot tweezers tip is not gonna be enough to take this big diode off, so we're using hot air and the hot tweezers. right there. And let's remove this one too. Oh, the microscope camera is not on. Oh boy. I removed the two diodes. I prepped the pads by adding leaded solder here, leaded solder here. We did the same thing here. Applied leaded solder here and leaded solder here. And all we have to do is solder two new diodes, and hopefully this iPad will work again. Now, what I did not keep track of is the orientation of the diode. So I'm gonna go back to the video, look at the orientation, and I'll be back. And let's see if we have those diodes. We have the V3 diodes. They should be the same. Let's check under the microscope if the size matches. Okay, I do not know if these diodes will work or not. The V3s, they should be the same diodes, but I think what I'm going to do is remove the diodes off an iPad Air. I have an iPad Air here, and these are exactly the same diodes that are on the iPad Pro 10.5, and they're also labeled JH. So let's go ahead and remove those diodes from here and put them on our iPad Pro. And let's go ahead and put it on the customer's tablet. Very good. So let's do this one with the soldering iron, so I can show you that we can use both hot air or soldering iron to do this. Now, if I want to make it perfect, I can use some hot air. Let's do that right now. So we just replaced two diodes, and we got the diodes off a donor board from an iPad Air, and we put them on here at the customer's tablet. Now all we have to do is put the screen on. We're gonna remove the separator that's going in between the battery and the board, and hopefully it works. Hey buddy, how are you?
I just call you success. Yes, battery is dead all
Okay.
the time.
All right.
This is
Battery. So about 20 minutes. We have to install a battery for a customer, 6S Plus. I told him 20 minutes. Let me test this quick. A lot of things to get done. A lot of things to get done. Not enough time. We're gonna test. Do we have an image? Do we have an image? Do we have an image? Yeah, I do not know if that battery, we may have to put the screw on top of the battery so it can make a good connection. Nothing. So we do not know if the problem is the customer's screen or there's other issues with the tablet. I'm gonna pause the video so I can finish the customer's battery, and I'll be back. Okay, so let's go ahead and test those diodes to see if the measurements are correct after we change them. 0.145. So this area is fixed. What about this one here? It should read 0.14 as well. And look at that, it's reading 1.9, 2.1. We changed this diode. We pulled this component off a salvage board. It looks like this component was bad to begin with. So we have to remove it and get another diode. I mean, anytime I pull a component off a salvage board, in back of my head, I'm always thinking, is this component good? Maybe this component is not good. And I do not give up on a repair when it doesn't work, because I'm thinking to myself, maybe that component that I pulled off from the donor board is not good. In this case, I'm able to test that component and it measured 2.1, which is not good. So we have to find exactly the same diode. I have a lot of iPad Airs here that we can use. Here. And this time we're going to test the diode before we take it out, just to make sure that the diode is good. I should have done that before. Let's test to make sure we get 0.14 on this one before we take it out. Very good, so let's take it out. But before we do so, let me remove it off the customer's board first, so the place is ready to accept a new component. Okay, now we can remove this component from here. Okay, and we're gonna put it right over here. Hopefully that fixes the problem, because if it doesn't, then I'm clueless to what's next. So let's go ahead and test. Reading on this. Very good. And reading on this. Very good. So both readings are good. All we have to do is test. Customer screen is connected. And let's turn it on. And it's on, but looks like the customer's screen is bad. And the customer did tell me that when he first installed the screen, a line came on and then it went off. So as you can see, the tablet is now working, but you have this black line in the middle. So not only did the customer damage the circuit board, but he also damaged the screen on this tablet. The customer tried to save money and now he's paying almost 3 times as much. If you are not an experienced person, do not attempt to change the screen on your own, because it's going to cost you a lot more money to get this tablet to work again. Now, I do not know if the customer has important information inside or he's fixing it for the sake of fixing this tablet, because it's not a cheap tablet. But either way, the tablet is now fixed. We just have to call the customer and let him know that his screen is not good, and if he wants us to change the screen. If we do not change the screen for him and he want to do it on his own, he may have to send this back to us again so we can replace those diodes again, or whatever the case may be. So I think he's going to make the smart decision and ask us to change the screen for him. It's up to him. Our job is done here, and I hope you enjoyed the video. Go ahead and like this video if you liked it. Don't forget to subscribe. Leave a comment if you have any questions, and we'll do something else in the next video.